Hello and good morning everyone. Today inshallah we will continue also on the solution of a system of equations. As you will see, time is flying. We are now in the fourth week of this semester. Okay, so I need you to keep up with me as much as possible. This is lecture number 1 for the fourth week. Tomorrow it's gonna be lecture number 2. Okay, so I need you to start working as hard as possible and also to review your notes and everything. You will find them on Moodle. I believe all of you have an access for Moodle, okay? And also I will send you the files most of the time using WhatsApp to amend that you have your files ready for you either on Moodle or on WhatsApp, okay? So I need you to keep checking about this. I have some problems with my still with my WhatsApp because I've lost all the previous messages, but in those cases or in such, this is why I'm sending some of the slides repeatedly for you to keep you safe from this. Okay, I want you to remember that we will start from the part of elementary matrices and how it is linked to the change of various matrices. There is a question I want to go with you through this lecture, but I will start by those slides. This slide is stating that an elementary matrix is a square matrix. Of course, we know about this because elementary matrix is a square matrix that's obtained from identity matrix. What's an identity matrix? What's an identity matrix? The unit matrix. What's the unit matrix? It's the matrix that we know, it's a square one, with a diagonal matrix. All the principal diagonals are positive 1, and it is the identity in multiplication. Okay? So it's just only 1 in dimension 1 by 1, 1 0 0 1 by rows for 2 by 2, 1 double 0 0 1 0, then double 0 1 if we are talking about 3 and 3 and so on. Okay? Okay. By identity matrix of the same order by performing a single elementary operation. Okay, what's the elementary operations? Judy, do you remember what's the elementary operations? Okay, what's the row operations that we usually do? We have 3 of them, 3 row operations. What are the 3 row operations? Switching rows, multiplying row by a constant number, multiplying a row by a constant number, then adding it onto or into another row or on another row. So I have 3 major row operations you have to keep in mind in all times. Those row operations can be also performed by elementary matrices. معايا نور? Okay? Okay. Let's do them one by one. Let's say, for example, this is a unit matrix, which is Karim 1 0 0 1. I want to multiply the first row by -3 and add it on the second row. So it's very, very simple. All I have to do, see, is multiplying the first row, so it's going to be -3 and 0. Then adding on the other, or on the second row, so it will change to be -3 and 1. Okay? This is the description of what we did. R2 dash or R2 new, it's gonna be consisting of multiplying the first row by -3 and adding it on R2. Okay, so this is the elementary matrix of multiplying a row by a number, then adding it to another row. Okay, let's look to this elementary matrix, which is an identity matrix 3 by 3. If I want to multiply the second row by 5, it's very, very simple. I will multiply, so this is the form of this matrix that we have. Okay, the third row operation is switching rows. So if I want to switch R1 instead of R4, all I have to do is just to replace these 2 rows. So I'm having 0 0 and 1, and then I will have 1 double 0 or 1 triple zeros, as you can see. So that's an elementary matrix which explains that I will multiply the first row by -3 and add it on the second row. That's a matrix representing that I will multiply in matrices, and it's of dimension 3 by 3, and I'm multiplying the second row by 5. And that's a matrix representing that it's a 4 by 4, okay, operation, and we are switching rows R1 and R4. Okay, So these are called elementary matrices. That's an elementary matrix, that's an elementary matrix, that's an elementary matrix. The elementary matrix usually do just only one operation by the time. So each elementary matrix, it will do one operation. If you remember in the previous session, while we are solving a system of equations, we started by forcing the first number in the first row to be positive 1. Then using it to force the number beneath it to be zeros. So we actually may make more than one operation in one setting, okay? And we will remember this, and I will get back to it in solving a system of equations together later. So it's not going to be possible by by elementary matrices, because each an elementary or each an operation will be done by just only one elementary matrix. Okay? Very good. Okay. Why we use elementary matrices? Okay, there is a one-to-one correspondence between elementary operations, the row switching, multiplying row by a number, multiplying row, and elementary matrices. Multiplying an elementary matrix E to the left of a matrix A consists of applying the row operations to A by elementary operations corresponding to it. Which means that instead of just playing the rules, playing with the rules, multiplying the first or moving the rows and so on, I can do the same by multiplying the matrix that I want to change by an elementary matrix. Okay? Each step with each other. This will help me down the road to know how to put an inverse altogether, or how to explain a matrix as an operations of elementary matrices, as we will see. Okay, for this problem, let's see. This is 1, 2, 3, and 4. Okay, if we multiply the first row by -3 and add it on the second row, the result will be as you can see. -3 plus 3 is equal to 0, -6 plus 4 is going to be -2. This is how it's going to be done by elementary matrices. So, here, Ms. Salma, I did it on my own. Okay? Just multiplying the first row by -3 and add it on the second row. I can do exactly the same using an elementary matrix. How to do it? I will do this process first on an identity matrix from the same dimension. Then I will multiply. So, bottom line, I need to multiply, I need to change R2 to be -3 R1 plus this R2. And that's the final result. I will do this, but in a unit matrix. That's the unit matrix. Multiplying the first row by -3, so it's going to be -3 and 1, and -3 and 0. Then adding it on the second row, which is 0 and 1. So that's an elementary matrix expressing or corresponding to the same row operations out. If I multiply this matrix by the main matrix, this is the result that I have. So there is a correspondence between the row operations and the corresponding elementary matrices, as you can see. Okay, if I have a matrix and I want to multiply the second row, let's say in 5. If I multiply the 5 in a unit matrix, it's going to be from the same dimension, so it's going to be 3 by 3. It will be 1, 0, 0, 0, 5, 0, 0, 0, 1. Here we go. If I multiply this matrix from the left to the main matrix, I will have what I want. It's exactly like this one. Okay, also, if I want to switch rows, let's see here. That's the general matrix. If I want to, or the main matrix, if I want to do a row operation, switching row number 1 with row number 4. So the result will be 4, 4, 4, 4, and this is going to be 1, 0, 0. I can do this exactly the same by doing this process first in a unit matrix, then multiplying the unit matrix by the original matrix. The result will be the same. So they are corresponding to each other. Okay, each elementary matrix is invertible. This is very, very important. So at the time being, I saw that all the row operations can be done by using elementary matrices, which is mainly a unit matrix we do the process in it, then we multiply in the main matrix, then we will have the row operation started. Okay? There is another info that each elementary matrix can be invertible, or the processes can be invertible. How to invert this? Okay, let's remark. This elementary matrix multiply the first row in -3 and add it on the second row. If I want to reverse this process, all I have to do is to multiply the first row by +3 and add it on the second row. Okay, that's the inverse of the operation. So here is the operation, and that's the inverse of this operation. Here we multiply the first row by +3 by -3 and add it on the second row. If I want to reverse it, all I have to do is to multiply the first row by +3 and add it on the second row once more. That's the inverse. If I multiplied a row, a specific row by a number, we here multiply the second row by 5. If I want to reverse it, I will multiply the second row by 1/5. Here we go, by 1/5. Also, if I want to replace the fourth row and the first row, those are replaced. Really? Replace them once more. So that's the inverse. So one of the advantages of using elementary matrices is we can see easily that we can the process and we can reverse it. Okay? By using elementary matrices, as you saw. Very important slide. This slide is really very important. It expresses how to get an inverse of a matrix using Gauss elimination method. How to get the inverse. And it is also explained by the sequence of elementary matrices. I will go through this slide once more in details, but after we finish or we solve this equation or this matrix first, or this problem first. It will explain everything. Here I need, how can I write a matrix A as a product of elementary matrices? By the idea. This problem in specific was a training example in SBE. Okay? I did it with SBE and I did it with FCT, and I will do it with you also. This is really very good example to explain what's happening. So first of all, I want to get the inverse of this matrix using Gauss elimination. Any one of you remember, or did we do it previously? How to get that inverse of a matrix? Okay, we write the main matrix, then we write a unit matrix, then we go through the steps of having a reduced echelon form, we will get the inverse. Okay, Mr. Ziad, in order to get the inverse of this matrix, which is 1, 2, then 3, and 4. We have plenty of methods to use it. I will focus now just only with the Gauss elimination method to get an inverse of this matrix. It's really very nice method to get an inverse. I will start with writing the matrix that I want to get its inverse to the left. And I will open an equivalence line, a line that will be equivalent for this matrix and the unit matrix that I'm going to write. This is 1, 2, 3, and 4. Then I will write a unit matrix from the same dimension, 1, 0, 0, 1. I will use my row operation to make, or to force, Judy, this matrix to be on a reduced echelon form. What do we mean by a reduced echelon form? To change this matrix to be a unit matrix. What's going to appear here, it's going to be the inverse. So once more, I will start to change this matrix to be a unit matrix. What's going to happen here is the inverse. So let's start. In order to do this, which is really very near to solving a system of equations, is Mr. Ziad, to have the pivot of the first row first equal to +1. Then using the first row to force the elements beneath +1 to be zeros. So all I have to do is to multiply the first row by -3 and add it on the second row. I will do it on all the matrix by itself. Let's do that. So what I'm going to do first is having R2 dash. I'm going to change the second row. I'm writing in order to be able to get the elementary matrices. I want to change the second row. How I'm going to change it? Simply by multiplying -3 times R1, then add it on R2. This is what I'm going to do. So I've explained already what's happening. Okay, let's do it together. Once we do this, the result will be the first row will be as it is. So it's 1, 2, 1, and 0. Multiplying the first row by -3 and adding on the second row, let's do it together. -3 plus 3, it's gonna be 0. -3 times 2, it's gonna be -6. معاك 6? Plus 4, so it's gonna be -2. -3 plus 0, so it's gonna be -3. -3 times 0 plus 1, it's gonna be +1. So simply, Kareem, I've multiplied the first row -3 and added on the second row. So it's gonna be -3 plus 3, -3 plus 3 is 0, -6 plus 4 is -2, -3 plus 0, -3, -3 times 0 plus 1, it's +1. Okay. The second step, Mr. Ziyad. As you can see, the pivot is +1 and the first column is correct. I will move now to the pivot of the second row. I need this guy to be +1. How to change -2 to be +1? Huh? Good. Then I will make a change also in R2 dash. This R2. How it's gonna be changed? I will multiply -1/2 times R2. صح؟ اتفضل.
مفيش طريقة تانية غير الجواز.
مش بكيفنا.
ايه ده؟
مش بكيفنا. لازم تتعلم.
انا قلت في كذا طريقة.
في 500 طريقة انا قلتها لك قبل كده. الطرق اللي فاتت حاجة ودي لها هدف دلوقتي. انا عارف انك تعرف تجيب الانفرس. لانك تعرف تستخدم الامبيريكال رول. Which is simply 1 times 4 is going to be 4 minus. Okay. If I want to get the inverse, just do it.
Okay.
But this method, we already know how to use it in Gauss elimination, solving a system of
انا
equations.
ما بعرفش استخدم الجاوس elimination الا مع 2 by 2 اكتر من كده بتغلط.
لا ما هو لازم نعالج موضوع اللخبطه ده بانك تصولف more than once. بس في الوقت الراهن انا عايز ده تشيله من دماغك.
ايوه.
انا اللي انت ما بتفهمش اكتر من 2 في 2. انا عايزك تركز حالا بس في ان انت شفت الرو اوبريشن دي اتعملت ازاي. دي السكند رو اوبريشن اللي احنا عملناها. وفي الوقت الراهن وقت ان انا اعمل لها ابلكيشن شكل الماتريكس بتاعك هيبقى شكله عامل ازاي.
انا دلوقتي هضرب الرو اللي فوق بلس تحت في 2.
مش ده اللي انا كاتبه. ايه اللي انا كاتبه؟ انت قول لي. هتشينج R2 صح؟
ايوه
هتشينج R2 ازاي؟ هضرب R2 القديم في -1/2 عشان اخليه +1. اشتغل. يبقى -1/2 times 0 is gonna be 0. -1/2 times -2 is gonna be +1. -1/2 times -3 it's gonna be 3/2. -1/2 times 1 it's gonna be -1/2. So we simply multiply the second row by -1. Why, Mr. Ziyad? Just to get this pivot equal to +1. The first row will remain as it is. هذا الفيرست row زي ما هو 1 2 1 and 0. الفاينل ستيب انا عايز above this 1 I need this number to change it to be a 0 in order to have a reduced echelon form. صح؟ يبقى إذا هروح أكتب الديسكريبشن. اديني الديسكريبشن كده بتاع البروسيس اللي أنا عايزها. مين الرو مستر زياد؟ مين الرو اللي أنا عايزه يتغير؟
رو 1.
صح؟ يبقى رو 1 الجديد رو 1 داش النيو رو 1 أنت عايز تعمل فيه إيه؟ ده هجيبه عن طريق إن أنا I will multiply R2 in -2. Then I will add it on R1. يبقى R1 الجديد اللي انت هتجيبه ازاي؟ هملتبلاي الرو ده في -2 وادد على الفيرست رو. انا كتبت الديسكربشن اهو. معايا كريم؟ Okay, do it with me, Mr. Ziad, step by step, element by element. So I'm not going to change R2. R2 is not going to be changed. Okay. هيبقى 0 ها 1 ها 3 over 2 minus half. Then I will multiply all of these elements in negative 2, then add them on first row. معايا مش جودي؟ وأنا ليه حسيت مش معايا؟ Negative 2 times 0 0 plus 1 is gonna be 1. Negative 2 plus 2, so the result will be عملت اللي أنا عايزه يا زياد. Negative 2 times 3 over 2 negative 3 plus 1 هيديك كام؟ Negative 2. Repeat. Multiplying in negative 2, it's going to be positive 1. Plus 0, so the result will be. So now I've multiplied the second row in negative 2 وadded على first row. Let's do it quickly. Negative 2 plus 2, negative 2, negative 3 plus 2. It's going to be, okay, perfect. At the time being, as you remark, we changed the main matrix, Ya Omar. We changed the main matrix to be on a reduced echelon form. That reduced echelon form. صح? What happened, Kareem, that the unit matrix, it changed to be another matrix. Let's check the last matrix. The last matrix that I had is simply, I will write it here. The last matrix is negative 2, positive 1, 3 over 2, which is negative half. Let's multiply them together. لو أنا جيت أعمل لهم multiplication، إيه الريزلت اللي هتحصل؟ إيه النتيجة اللي هتحصل؟ Let's do it. Multiply the first row by the first column. ها شباب. 1 times negative 2 plus 2 times 3 over 2, it's 3. So that it will be positive 1. Multiply the second row by the second column. It's going to be positive 1, then negative 1. The result will be multiplying the second row by the first column. So it's going to be negative 6 plus 6. The result will be multiplying the last row by the last column. So it's going to be 3, okay, minus 2, which means that's matrix A, and that's matrix A minus 1. Another main remark. Another main remark. This is really very important. Please don't write anything, just watch me. From this operation, I can write the corresponding elementary matrix. The new elementary matrix, or the elementary matrix responsible about this action, is simply multiplying the first row by negative 3 and adding on the second row. So that's the first row of an elementary matrix, of an identity matrix. Multiplying the first by negative 3 and added on the second row, that's the operation number 1. I will call it E1 for this time. So that's the first operation that you did. The second operation, Mr. Ziad, انت بتتكلم في وقت فعلا كريتيكال. دي رو اوبريشن رقم 2 اللي انا عملتها بالاليمنتري ماتريسيز. ده شكلها بص كده E2 ستيب نمبر 2. ايه اللي حصل في ستيب نمبر 2؟ انا I've multiplied the second row يا عمر by negative half. So it's gonna be 0, negative 1 over 2, 1 and 0. That's the second elementary operation corresponding to the second row operation that we did together. Okay, let's do the third elementary matrix. The third elementary matrix is, that's the third step, E3, is, remark, please. Multiplying the second row of a unit matrix and add it on the first row. So multiplying the second row in a unit matrix, it's gonna be 0 and 1. Multiplying negative 2, so it's gonna be 0 and negative 2. Added on the first row, so it's gonna be positive 1. So if you remark, this is the row operation expressing or corresponding, this is the elementary matrix corresponding to this row operation. We have multiplied the second row in -2 and added on the first row. I did the operations. This is number 1, that's number 2, and that's number 3. So actually what happened, and this is really very important, we started by the A matrix. That's the A matrix. We multiplied by this elementary matrix, which is E1. And then the result, that was the result. We applied on the result, multiplying the second row by -12. So that's actually operation number 2. And on the result of what happened, we changed R1 by multiplying in -2, which means we multiplied in E3. This is what happens on the left side. When you take matrix A multiplied by A1, the result will be multiplied by A2, the result will be multiplied by A3. We found ourselves in front of a unit matrix. This is the unit matrix that you have. Which means, Ya Mursi, that E1, E2, E3 is actually A minus 1. So A minus 1, the inverse of the matrix A, لو سمحت خليك معايا. That the inverse of matrix A is the operations E3 times E2 times E1 with this order. يبقى أنا دلوقتي قدرت ألاحظ الآتي. إن الانفرس هو عبارة عن مجموعة من الإليمنتري ماتريسيز مضروبين فين؟ في بعض. أنا مسكت الماتريكس الأولانية، عملت تشينج اوف روز. I'm sorry, multiplied a row of number وجمعت الرو اللي تحتي. مسكت الريزلت ورحت عملت مالتيبليكيشن للسكند رو ان نمبر. مسكت الريزلتس بتاعت all of them all. وبعدين رحت multiplied by a number وادد على الفيرست رو. الثري اوبريشنز دول بالظبط زي ما يكون. ضربت مجموعه من بالاليمنتري ماتريسيز في بعض. الاليمنتري ماتريسيز في بعض دول هم مين؟ هم الانفرس. ده اللي بيكسبلينز ليه لما ببدا بماتريكس بالوضع ده وامشي بيها ستيب 1 ستيب 2 ستيب 3 تظهر البروسيجر زي ما حضرتك شايف. طبعا خلي بالك ده كمان له معنى تاني. ان انا لو حبيت اجيب ماتريكس A as a product of elementary matrices اقدر. لو حبيت اجيب ماتريكس A as a product of elementary matrices اقدر ازاي؟ مش E3 times E2 times E1 times A بيساوي I. يعني لو انا ضربت في الانفرس بتاع E3 E2 E1 هقدر على طول اجيب اليمه الثانيه الريفرس بتاع البروسيس دي. يعني لو انا حبيت اجيب انفرس فور بوث سايدز او اودي الفاليوز دي في الاذر سايد هقدر اجيب ماتريكس A as a product of elementary matrices. طيب تعال بص كده اقدر اقول ان ماتريكس A بتساوي، لاحظ، E3 في E2 في E1 to the power of -1 times I. انا جبت الثلاثه دول واديتهم الاذر سايد as an inverse. وانا اقدر اعمل ده. بس عندي واحده من البروبابيلتيز مستر كريم بتاعت الانفرجن المالتيبليكيشن. افتكر ان انا كان عندي بروسيس مهمه قوي وهي انه لو انا عندي A times B to the power of -1 لو انا بجيب باكسبريس ده هيساوي B minus 1 times A minus 1. This is how to distribute a power on a multiplication. This is one of the propositions that we did go through the propositions of inversion and the proposition of multiplication. If I have two matrices multiplied in each other and I'm bringing the inverse, the result, how it's going to be? Just replace the order of this multiplication and get the inverse of each one of them. So this is really major. Now I have the inverse of these processes. See how I'm going to rewrite it. So A matrix is going to equal to E1 to the power of -1 times E2 to the power of -1 times E3 to the power of -1. If you remark, I have reversed the order of the operations. دول كانوا E3 في E2 في E1 كلهم بجيب لهم انفرس. لكن هنا انا فكيت كل واحده فيهم لوحدها. عشان افكهم لازم اتشنج الاوردر بتاع الاوبريشنز. معايا جودي؟ يبقى بدل ما ده E3 في E2 في E1 انا بدلتهم خليتها E1 في E2 في E3. السؤال مس سلمى، مين هي الE1؟ السؤال للكل. عمر، حسين، مين هو الE1؟ بص على الE1 اهو. انا عايز اجيب الانفرس بتاعه يا سلمى. How to get the inverse of this matrix؟ انا لسه قايله في السلايد اللي فات. بدل ما كنت بعمل مالتيبليكيشن في نيجاتيف 3 هعمل مالتيبليكيشن في بوزيتيف 3. يعني ده معناه ان الماتريكس E1 to the power of negative 1 هو simply نفس الماتريكس الاولانيه بس انا I will reverse the operation. reverse الاوبريشن يعني تبقى ايه؟ هتبقى 1 0 بوزيتيف 3 and 1. ادي الفيرست ماتريكس. E2 negative 1 هي E2 كانت بتعمل ايه؟ multiplying the second row in negative half. How to reverse it? I will multiply the second row in negative 2. So that's the second matrix, which is simply 1 0 0 and negative 2. The third operation, تالت واحدة. The third operation, we multiplied the second row by negative 2 we added on the first row. How to reverse it? Simply by multiplying the second row in positive 2 and add it on the first row. So it's gonna be 0, 1, then 2 and 1. اللي أنا كتبته ده ماتريكس إيه؟ يبقى actual اللي حصل قدامنا هنا او البروبلم دي باي اتسلف شرحت حاجات كتيره جدا. شرحت رقم واحد ازاي اربط الرو اوبريشن بالاليمنتري ماتريسيز. ارجوك لو انت مش مركز من البدايه دلوقتي لازم تركز لان انا بعيدها تاني. يبقى اول حاجه اتشرحت ازاي بربط الرو اوبريشن بالكورسبوندينج اليمنتري ماتريسيز. هنا بدات اشوف الرو اوبريشن. طبعا انا عارف انا بعمل ايه. انا عندي دي المين ماتريكس وانا بتشينج بالرو اوبريشنز عشان اجيبها يونت ماتريكس. وعارف ان اللي هيحصل فيه تشينج من هنا ده هيبقى الانفرس. ده مبدئيا انا شايف انا رايح فين. يبقى ده ستيب نمبر 1. multiplying first row by negative 3 and added on the third row يا سلمى دي الاليمنتري ماتريكس اللي بتعملها. يبقى انا ربطت الرو اوبريشن بالاليمنتري ماتريكس. الستيب رقم 2 انا ضربت السكند رو في رقم دي الاليمنتري اللي بتعمله. ستيب نمبر 3 عملت العكس multiplying second row in a number وادت on the first row ضربت الصف الثاني في رقم ضربته على الاول. دي الاليمنتري ماتريكس اللي بتعمله. يبقى انا جبت الثلاثه اليمنتري ماتريسيز الكورسبوندنج للثلاثه رو اوبريشنز اللي انا عملتهم. لما عملت الرو اوبريشنز دول جبت الانفرس. يبقى ده معناه ايه كل واحده من العمليات دي؟ ان انا ضربت اليمنتري ماتريكس من دول من الشمال في الماتريكس رقم ايه؟ نور. ده مشروح هنا. بص ادي الماتريكس ايه؟ لو انا ضربتها في E1 هتضرب الصف الاولاني في نيجاتيف 3 تجمعه على الصف الثاني. طب الريزلت خلاص اتغيرت اصلا. مجرد ما اضرب في E2 يبقى الصف رقم 2 اتضرب في نيجاتيف 1. مجرد ما اضرب الثلاثه بعد ما طلعت ريزلت ليهم في E نمبر 3 راح مفاينلايز الشغل. وصلت للمرحله الاخيره خالص. يبقى هنا انا عملت الرو اوبريشنز بسرعه جدا. هنا عملتهم بالترتيب. معايا حسين؟ ضربت ايه في E1 عملت الحركه الاولانيه الريزلت. ضربتها في E2 عملت الحركه الثانيه الريزلت. ضربتها في E3 عملت الحركه رقم 3. يبقى ده معناه ان ال E1 تايمز ال E2 تايمز E3 بنفس الترتيب ده مستر محمد. هم دول اللي اسمهم مين؟ انفرس. حلو جدا. يعني اذا انا دلوقتي عارف ان الانفرس اكسبليند بالنسبه ليك as a multiplication of مين؟ elementary matrices. السؤال اللي كان موجود هو عايزك تو اكسبريس ايه دي as a multiplication of elementary matrices. يعني عايزك تحلل ماتريكس ايه دي انها مجموعه من الاليمنتري ماتريسيز مضروبين في بعض. اقدر اعمل ده دلوقتي. مش انت دلوقتي عندك A minus 1 في A بيساوي I؟ اوكي؟ يعني لو انا ضربت البوث سايدز في A من الليفت هيبقى A في A minus 1 يعني بواحد، مش يفضل ال A بس. وال A minus 1 في I اللي هي دول. اهو ده ال A minus 1. اهو انا حطيت الريفرس بتاع ال A minus 1. ادي ال A ماتريكس. يبقى دي هتتضرب في الاي، دول هيدوني الماتريكس رقم A as elementary matrices. حته صغيره قوي موجوده هنا من البروبوزيشنز مس جودي، ان لما بجيب انفرس الماتريسيز اوريدي مالتبلايد في بعضها بيري اوردر ذم. الاي 1 تروح الاول، اي 3 يروح في الاخر، لان بتشينج الاوردر. جاي منين؟ من البروبابيلتي دي. وكل واحده فيهم اتعمل لها ريفرس انفرس، فبالتالي عرفت تو اكسبلين ايه از ا برودكت اوف 3 ماتريسز. بغض النظر عن البروبلم باي اتسلف، المساله دي اهميتها انها وضحت لك كل اللي انا عايز اقوله لك دلوقتي، او كل اللي احنا كنا بنفكر فيه. انا همشي بالستبس، خلاص انا تقريبا بخلص الجزء ده، بعدين هخش لك بقى على السلايدز بتاعت ليسبن ستيب 1 باي 1. استنى نشوف بس الابديت ده. بسم الله الرحمن الرحيم. Just a second.
ايه؟ حاجة